Okay, so let's start with part one. Okay, as you can see over here, this is actually the algorithms. Okay, the component of algorithm for decision logic structure. Okay, if for sequential logic structure, okay, the algorithm, the important part in algorithm is mainly just input, outputs, and calculation. Okay, so in addition for that, okay, for decision logic structure, we are going to use the keywords if, okay, then, and also else. Okay, if, then, and probably else. Okay, if we are going to if we are needed to use else, then we are going to use this. Otherwise it is only if and also then. Okay, this is a keywords. Okay, that's why you can see over here optional, kan? Optional is for the else lah. Sometimes we are going to require to use else, sometimes you don't have to use else. Okay, we are going to see the situation. Okay, both of the situation. So this is a general algorithm. So how we are going to apply this later on. Okay, so if is in front of the algorithm related to decision, okay, and then the conditions, okay, and also you need to put the keyword then. Okay, if, then condition is the conditions. We are going to look at what are the condition can be put over here, and then the keyword then. Next, you need to put a space, okay, which is the indent. Okay, space, put a space, and then you put the any instruction that is true, that is true for this condition. Don't get confused just yet. Okay, this is just in general. Okay, how we write down the algorithm, and then else. So this is if the condition is false. Okay, if the condition is true, this is what we are going to do. Else, meaning that if the condition is false, so this is what the system is going to do, right? And then we terminate the condition with an if statement. So this is the general algorithm. Okay, just in general. Okay, so this is if the condition, if the system required to have both true and also false. True and also false instruction. This is the different. Okay, if it is required for you to have false instruction, then you need to have else over here. If the condition only required the true instruction, there's no false. Okay, then this is the algorithm. That's it. No else. This is optional, kan? Based on the case study. Right? This is the different. This is if without else. Right? Okay, in general, kan? Nanti, don't get confused just yet. Alright. So what should we put inside of the condition? Inside here. Okay, what should you put? How to extract the information from the case study or the problem, kan? And then what should we take from the problem? So we are going to look at the problem and identify. Identify all these operator. Alright. If you can see inside of the statement or the case study, there is an operator. Okay, there's a statement that you can convert to this all these operator. Then probably it is the condition. It is a condition for the uh, for the for the system. Okay, because the output of a condition, okay, the output, ini bukan output for the system, the whole system. The output of a condition is mainly about either true or false. Okay, it cannot be a number, kan? It cannot be a number, it cannot be a character, it cannot be any other things other than true or false only. Okay, ingat the conditions mainly, the output for the condition is either it is a true condition or it is a false condition. That's why we are going to use logical expression because logical expression, okay, logical expression that involving the and or and not operator, mainly the output is true or false if you still remember this from last week remember or not? For example, A and B A and B. A is true, B is false. So the output is
False.
false cannot be the output cannot be a number cannot be 100 So it is either true or false. Okay, that's why this is suitable for what we are going to put in the condition. Excuse me. Okay, sorry. Okay, continue. And the second one is uh, related to relational operator. Okay, so this might be inside of the condition. Okay, right. And also it is a combination. It can be a combination of these two lah. Okay, logical operator and also relational operator. Okay, that what we are going to put inside of the condition. Ni condition. Right. Okay, example. Okay, example A less than B, X plus 5 more than or equal to Z. So this can be, for example, this can be the condition over here. Sini lah. So this is how we write down the condition. For example, if A less than B, okay, probably A is let's say we said A is 100 and B is 2. Okay, so this is true instruction, false instruction. So what's going to be for the algorithm? Is it true or false?
False.
False.
So the output, it's not really the output, the outcome lah, okay? That's the output you are going to confuse with the screen output the outcome the outcome of this decision, okay, is false since A is more than B. So this statement, the condition is false. So the system is going to skip, okay, the first true instruction and it will execute, okay, the else, because the else is for false instruction, okay, if the outcome of the condition is false, right? So let's say, okay, let's say number sama dengan 1, okay, for instruction. And this one, number equal to 2. So what is the output of number in this case? The output of number is number equal to 2. Okay, not number equal to 1. Okay, but if we change the input, okay, for A and B, so if the value of A and B is like this, so what is the value of number? Is it 1 or 2?
1.
Number is 1.
1.
Okay, simple, right? Okay, moving on. So this is a condition, okay, that you need to understand. Okay, the condition should be either true or false only. So you cannot put something like this, A equal to B plus 100. Okay, so this is wrong. Okay, this is wrong in so many ways. So it cannot give the answer that required by the decision. It cannot make a decision. So what is the output? The outcome? Is it true or false? You don't know, right? The outcome is going to be 102. So what is 102? Is it true or false? So it is wrong. Okay, so you cannot use this equation as a condition. So this is wrong. Wrong condition. So how to make it right? If you put it like this, then it is correct. What does this mean? Not equals to. Equals to. Yeah, equal to. But if this is also, you can say that this is equal, right? So this is equal to. Okay, correct. Okay. So this is comparing A and also the output of B plus 100. So if this is true, if A equal to B plus 100, then all right, this is correct statement. So if this is the case, is it true or false?
False.
It is false. Okay, so A is 1. Okay, A1 is not equal to 102, so it is false. So number equal to 2 lah. Okay, this is the statement is going to be executed by the system. Okay, number equal to 2. Right, don't get confused. Right, so this note, if you're already going through this note, it is slightly different from the one in Kallang. Okay, because I modified it to make it less apa less confusing. Alright. Okay, next. Okay, this is also an example of correct condition. Okay. Okay. Before we go before we go in details of types, okay, if you go up, okay, over here in part 2, there are 3 types of decision logic structure, which is straight through, positive, and negative. So this is a higher level of types. Okay, the one that we are going to, before we go through with this, okay, there are much lower types of decision, okay, which is this is a very basic. Okay, the lower types of decision. Okay, the one positive, negative, that one is higher types. This is lower before we going through the higher types. So in basic, there are actually I added one more over here, which is okay. If again, else if. Okay. Then we have the fourth one is case structure. Okay, just add over here. Make sure you take note on this. Okay, one more over here. The fourth one is case. Okay, if else, if else if. Okay, let's look at what's the difference. The first one is the if statement. Okay, if statement consists of one symbol. Okay, one diamond symbol. Okay, one diamond symbol. What should you put inside of the symbol? You put the conditions. Okay, first you need to identify the condition. Okay, after you already extract the information about the condition, okay, you turn it into expression. Okay, and then you put it inside of the symbol for the flowchart. Okay, inside of the diamond symbol. Okay, this is for the flowchart. Okay, for the algorithm, you put over here. Okay, you put it here. What is the mean of this condition, class?
Marks more than 40 or equal to 40. Also marks less than 100 and equal to 100.
So basically, marks is true if it is between what value?
40 to 100.
Yeah, correct. Okay, so this is true. Okay, okay, this algorithm is true. Okay, this condition is true if mark equal to in between 4 or 100. Okay, is it including 40? Okay, 40 and 100 n. Is it including 40?
Yes.
Yes.
Including 40 because it is more or equal. Okay. Right. So this is between 40 and 100. So if the marks is between 40 and 100, then status is pass. Of course, this is not a complete flowchart, kan? If a complete flowchart, it should have start. Okay, it should have start over here, and then it should have input. Kan? What's the input? What's the input class for this? What should be the input, you think?
Mark.
Okay, correct. So user need to enter kan, enter mark. Enter marks. So let's say user enter 30. What will happen? If user enter 30?
False.
False. So what will happen? Nothing will happen, right? If we are referring to this flowchart, this is not a complete flowchart, right? If you are referring to this flowchart, nothing will happen. So this is start. This is, let's say, n. So in this case, nothing will happen. For the false, nothing. This is if statement. If statement without else. This is if statement without else. So else is for the false statement. Yeah? Since there is no false statement, so it is only if without else. Get it? Can you follow, class?
Yes, sir.
Yes.
Yes, sir.
If you have any question, just ask me, okay? Okay, so this is the first time and the most basic if statement. Okay, if without else. Okay. The second one is if else statement. Okay, since there is a else, you should also put the false statement. Okay, the statements for the false. Right. So let's look at the same example over here. Okay, so now we have else statement. Same thing, okay? Else statement. So we have start and then we have input, okay? Enter marks. So if user entered 30, okay? User entered 30, it will give false. So the status is fail. Okay, and then it will end the statement. Okay, understand? Okay, what if I want to add one more statement before the end of the algorithm? Okay, let's say for the algorithm and we have start and then we have enter marks. And before end, I want to print status. If this is the algorithm, what should be the flowchart? How we want to modify this flowchart to match with the algorithm? Where should I put the print status?
After status. After the condition.
What if I put it over here? Is it correct or not? Okay, let's say I put it over here.
Wrong.
Wrong.
Oh, yeah. And also, I put the same symbol in status over here. And then I put this one straight away N lah. So this is N. Is this similar with the algorithm? Is it similar with the algorithm? Who said this one is similar? Anybody? Similar or not?
No.
Not similar.
I think yes. I think.
Yes.
Similar. Alright. So let's look at the full flowchart kan. So this one user need to enter marks. Okay, so let's say user enter 30. So 30 is false. So it will generate status equal to fail. So print status. So it will print fail, right? N. Okay. And let's check the algorithm. Okay. User enter 30. So 30 is not between 40 and 100. Okay. So it will not execute status. This is like this. Supposedly algorithm kan. Algorithm is official. So it will skip this statement and it will do else. And then status equal to fail. And if it will print status which is fail. So the output is similar, right? Correct. The output is similar, but the process is different. So let's say if you are given this algorithm and you were asked to convert it into a similar flowchart, if you do like this, is it correct or false? The answer is false. It is not similar with this one. Okay, it is a different process. Okay, this you have two. Okay, this you have two print statement. One inside of the true body of the condition. The second one is inside of the false body of the condition. So if this is similar to algorithm, it should have print over here. Okay, it should print status, and also over here another one is print status. So this is similar. Okay, there are no print status after an if. So this one is similar. Okay, you get it? But if this is the one that you need to convert, so this is wrong. Okay, the one that is correct is there is only one print status outside of true and false body. So this is outside of true and false body. Okay, where true and false meet, and then it will have one more arrow downwards, okay, towards the print status symbol. This is the correct one that is matching with this algorithm. Boleh?
Boleh, sir.
Boleh.
Okay, please understand the difference. Okay, so this is very important. Okay, so meaning also, let's say if we have multiple statement for the true condition kan. For example, there's equation over here. A equal to B plus C. And then we have print A over here. So what should we put inside of our flowchart? Where should we put A equal to B plus C equation in the flowchart?
In the true section.
Yeah, true body So it should be put after status equal to pass. So over here insert yeah. So this is where you put A equal to B plus C and then print A here. Print A. And then outside baru you print status kan. Okay. Okay.
Okay, sir.
Any question so far?
So far, so good, sir.
Okay. Okay, next is the third type. Okay, which is if, else, if. Okay, if, else, if. Okay, this is an upgrade from this. So this is where only one condition to be checked inside of the system kan. The marks is based on the marks. Okay, the outcome is either you pass or fail. Okay, either pass or fail only. Okay. So we upgrade it to include more criteria. Okay, more criteria to be checked by the system. Okay, so as you can see over here, there's a table. Okay, so if you get this a table and like this, it will actually make your life easier. Okay, to extract the conditions. Kalau if you get this, then straight away you can see kan. You can see clearly what are the conditions that need to be put inside of your system. So kan? So how many conditions that you can see over here? How many conditions that you can see?
5.
5 condition. Yeah, correct. The first condition is if. You see, if you can extract the word if, then meaning that it is a condition. Okay. If what? Between 0 and 39. If what?
Marks.
If marks. Kan? If marks between 0 and 39, then what?
The grade is E.
If mark between 0 and 39, grade equal to E. Alright. Else, else if marks between 40 and 49, then grade equal to D. This is a condition statement, okay? Right, so you just take this, okay, and fill out the algorithms. So the wheel system based on mark ni. Jangan pula ni nanti. Kat sini sikit. Okay, enter marks. Sini sini. And then for the body of Ni kan tadi kan, macam ni kan. Ini indent meaning that this is belong to else. This is similar with if, else if and if. So same level. Okay, this also should be same level. Okay, that by doing this you will easily recognize which belong to which. Okay. Right, so just modify this, enter marks, and then if marks is if mark if mark more than equal to what? For the first condition.
0.
Yeah, 0 and marks less than
39.
equal, okay, 39. Okay, if you put 40, is it correct?
No.
Is it correct?
Remove equal.
No.
Huh? If you put like this, meaning that 40, 0 to 40, you will get E. No, right? Because marks is less than or equal to 40. So 40 also you get E. So this is wrong lah. Okay, this is wrong with the table given to you. Okay, so it should be either you put less than 40 or you put less than equal to 39. It is similar meaning. Okay, why I said this one is similar meaning? Is it include 40?
Oh,
Mark less than 40. So it is not included 40, okay? So maximum is 39. If 40, then it is wrong. So it is similar. So you can put like this also. So same meaning as marks less than or equal to 39. Alright? Then, what? What should we put over here?
Grade equal to E.
Yeah, correct. Grade equal to E. Or the correct one is like this. If it is a character. Okay, character value is like this. If numeric value, you can put like this. If it is a string value, you put like this. String. So this is, supposedly you put value for character. For example, fill and fill supposedly like this. Value for string. Okay, next. Else. This is multiple condition. The previous one we are only focusing on single condition. Okay. If statement also single condition. Okay. The first one. Okay. Single condition. The second one also single condition. Okay. The third type is multiple condition. So multiple condition, we are going to link all the condition with else if statement. Okay, else add another if over here. Okay, and then continue with the condition. So what are the next? What is the next condition? What is the next condition?
Grade D.
What is the grade D? What's the condition?
Marks 40.
Yeah, don't forget to put the condition. Marks more than or equal to 40. This one you can just follow kan. If the condition is similar kan. Marks less than 50 boleh kan. Or less than equal to 49. Okay, then unbold. Okay. Okay, then grade equal to D. Right. Next what?
Else if.
Yes. Else if marks. Okay, saya pun malas. Copy lah. Okay, copy. Okay. So it should be 50 less than what?
60.
70.
70.
70. Okay, so the grade is C. Okay, and then we have another one. Go to pelik lah pula.
Salah tu.
Tukar ayat This one supposed to be 70 lah. Okay, Len. Betul Len? Is it correct?
Betul, betul.
Okay. And less than 80, grade is E. And last, what should be the last condition?
Else.
Okay, so the last condition, you must not put the condition. Okay, the last one, it's supposed to be else. Okay, if, else, if, the last one should be else. Don't put any condition for the last one. Okay, leave it empty and then just put grade equal to what?
A.
A. So this is how you write down algorithm if it is involving more than one condition. Okay, let's say if you have 1, 2, 3, 4, 5 condition inside of your algorithm, you should have 1, 2, 3, 4. Okay, condition minus 1. Okay, if you have 5 condition inside of the algorithm, you should have only 4 condition. Okay, written. Okay, the last one, you just take out the true statement. Okay, for that particular condition that you already removed. In this case, you remove the last condition, 80 between 100. So remove the condition, take the true condition, which is grade equal to A, put it inside of else body. Else without if. If there is a if, over here, it should have condition. So since this is the last condition, you should not put if. That's the rules. Okay, that you need to follow. Okay, we have if and we have else at the bottom of the statement. And then you conclude with an if. Okay, so print what? What should I print over here?
Grade.
Great.
Great.
Print grade. Okay, that's it. So this is your algorithm. Okay, computed algorithm. Any question?
Sir,
Yeah.
if like we want to start with A first, is it okay?
Okay, no problem.
So that the last else will be E, grade
Yeah,
E.
correct. No problem. Okay, I will show you why there is no problem. Okay, you will see clearly if we convert this into a flowchart. Okay, next task is how we represent this problem by using flowchart kan. Flowchart ni malas sikit. Okay ni, panjang ni. So flowchart. Okay, so let's draw the flowchart using words. Okay, so we start with start symbol and then okay, enter the marks. Okay, and then we go to the first condition. Okay, so remember,
Sir,
if,
sir.
yeah,
Sorry. You still present the PowerPoint.
sorry. Okay. Okay, boleh? Nampak?
Okay.
Right. Okay, enter marks. Okay, this is start kan? Start, itulah start kan? Aduh, mana start tu? Start, and then enter marks. So the first condition, okay, condition should be written inside of diamond. Okay, don't forget this. Don't use other than diamond. Okay, for condition, you should put the condition inside of the diamond symbol. So what is the condition? This is the condition. Okay. Okay, this is the condition. Okay. So if it is true, if true, so what will happen?
Grade
Should I
E.
use this symbol or this symbol for grade equal to E? Which one?
Square symbol.
Square rectangle.
Don't use it. This is for input and output. Unless if you put it like this, and if there is a print E like this, straight away you print, straight away you print, then you use the other symbol. Okay. So this is not print or input or output process. So this is assignment process. So use assignment symbol lah. This one. Okay. Grade equal to E. And then what happened? Okay, the flow of the process after, okay, let's say user enter 10. Okay, 10 is true. Okay, is it going to check the next condition, class? If it is true already. Is it going to check for the next condition?
No.
No, it will skip other condition, right? So it will straight away do what?
Print grade.
It will straight away print grade. Okay, dia tak masuk. It will not enter the rest of the condition anymore. It will just print the value of grade. Okay, print the grade which is done outside this is not computed yet. But what happen if user enter 100? Is it true? Let's say user enter 100. It is not true, right? So this condition is false. So it will go to the false body. So this is false body. This is true, this is false. This is how you write condition ini. It is either true or false. Okay, only. You cannot put another branch over here. Another branch, you put it over here. Okay, for decision if else kan. So what should you put over here kan? No, you cannot kan. It is either true or false only. Okay, only two arrow can come out from the decision symbol. True only. Okay, either true or false. You cannot have one more over here. So this is wrong. Okay, so for the false statement, okay, if the condition is false, it will go to where?
Another condition.
So similar as the algorithm. So if this condition is false, it will not execute this statement, but it will instead go checking out the next condition. So it will check the next condition, meaning that it will enter the condition kan. So this condition is represented by the symbol diamond, this one. So it will enter the next condition. Sorry. It will enter the next condition. If it is false, it will enter the next condition, which is marks between 40 and 50. Okay, you get it? So this is similar with the algorithm, okay? If this statement, this condition is false, it will check the next condition. Alright, it will check the next condition. Okay. So user enter 100 kan? User enter 100 kan? So 100, check this condition, false. And then it will check this condition. Is it true or false? 100.
False.
False.
Okay, it will false. False, it will go down. False. If it is true, then it will go here. True. This is true. This is false. Let's follow the flow for 100 marks. Okay, let's say it is 100 kan. False. Okay, we'll follow here false, and then we'll check the next condition. 100 kan? 100. So this is apa tadi? Ni 50 kan? 50 and 70. Oh, false. 100.
False.
Okay, still false kan? True over here. False over here. Okay. Again. Marks between 70 and 80. True or false?
False.
Still false. So what happens if it is false? What happens if it is false? Ini true kan? Ini true. This is true. This is true. What happens if it is false, class? How many conditions we have already? 1, 2, 3, 4. Maximum already, right? So this one we have 5 conditions. So if you want to transfer it into algorithm, so 5 minus by 1, only 4. So similar with flow chart. Okay, you cannot put another condition over here since this is maximum 4. Okay, so the last one is what?
Grade equal to A.
Yeah, correct. So the last false is else. Okay, which is this one. The last false. Okay, for all the conditions, you should put the else statement. Okay, the true statement for else. So this is else. Else is okay. Else grade equal to
A. A.
A. Alright. Okay, so you get it right. So fill in everything lah. So to make it a complete flow chart. So if this is true, then it will go to grade grade apa tadi? C, D, D kan? This is D. This one, if it is true, it will give the system grade C. So if this is true, it will give the system grade B. Else, if all the condition is wrong, if this is wrong, then it will give the system grade A. So this is else. That's why this is else. Okay, if others is wrong, else what then? So this is else lah. Okay, boleh?
Boleh, sir.
Boleh. So how we want to link all this together? What if I put, let's say if this is the flowchart. If this is the flowchart, I'm not saying this is correct. Okay, let's say this is how the flowchart looks like. And believe me, if I said you will do this, some of you will do something like this. Okay, let's check it out. Okay, check this flowchart. Right. Okay, you still can see it, right? Boleh nampak tak? Ke kecil sangat?
Boleh.
Boleh.
Boleh Okay, still can see Okay, let's check this flowchart whether it is correct or not. So let's say user enter 100. Okay, 100 for the case of 100 kan. So user enter 100 over here. So 100 true or false?
False.
False. Okay, true or false?
False.
False.
True or false?
False.
Okay, true or false?
False.
Okay, so grade equal to A. Print A. Correct, right?
Yes.
Correct.
Okay, correct. Okay, so let's test this with 0. Okay, let's test this with 0. So user enter 0. True or false?
True.
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 True kan? So 0, true. So it will go to this direction. Okay, to true direction, true body. And grade equal to E. Okay, correct?
Correct.
Okay, what happened? Update the value of grade into D. And then update value of grade into C. Upgrade value of grade into B. Print grade. So what's the printing value for grade?
Grade B.
B.
So grade equal to B. Is it correct?
Alhamdulillah.
No.
Wrong, right? So the output is not the correct output. So what should you do?
Add another arrow.
Okay, so you cannot do
Another way.
something like this.
Sir,
Okay, yeah.
kalau we put yang arrow ni bahagian tepi sekali. Macam mana cakap?
Arrow. Repeat.
Behind grade.
This arrow.
Yeah, right.
Okay.
Kat
So
sini and then kita buat connection.
yeah.
Like this.
That's the correct way lah. Okay, correct. So you cannot link all the output together because this is belong to specific condition, kan? This is belong to this condition. This belong to this condition. So it is not related. Okay, if you see from the algorithm, it is not related, kan? If this is true, you execute this, you are not executing this, and this. So it is not related. So similar as a flowchart. Okay, please don't do something like this. Okay. So it should be independent. Okay. All the true body for each of the condition should be independent from each other. Okay. Okay. This is how you can do it. So all the body will connected somehow outside outside of each true body, each of the condition true body, okay, something like this, okay, and then here you put print. Okay, this is the correct flowchart. Okay, baik. Any question?
No.
No, sir.
So this is to differentiate with the rest of the previous if lah, okay. So this is if your system have more than one conditions. So how to write it? If you have 5 conditions, okay, if you can detect 5 related conditions, 5 related, okay, this is all related, kan? Where we check only marks, okay, it is related, then you can do it like this. Okay, if it is unrelated, then you have to think of something else. So if it is, the condition is related, okay, if we have 5 sets of related conditions, then 5 you have to minus by 1. Okay, if you have 10 condition, 10 related condition, 10 minus by 1, so only draw 9 lah, okay, out of 10 lah. Only draw 9 condition out of 10. Right, the last condition shouldn't be appear, but the body, the statement, if the condition is true, you put it macam ni lah, kan, at the end of the flowchart, at the end of the decision lah. This meaning it is a else and else. Okay, boleh
Boleh.
So your midterm test will cover until this part lah. Okay, until multiple decision, okay, multiple condition. Dia macam ni lah, but it is not going to be something this easy, okay. Probably there will be no given table, okay. You have to extract the information and make it a table so that you can understand how to put all the condition all together, okay. If there's no table given to you, then you have to be creative lah. If there's a table given to you, then it is easier for you, okay, easier for you to construct the algorithm of flowchart. Okay, ada table senang, tak ada table susah sikit lah. Ya. Okay, next. Okay, next is case logic. So this is the fourth one. Okay, the fourth one is case logic. Okay, this is slightly different from if and else. Okay, so for if and else, we have single if. Okay, the first one. Okay, let's recap this. We have if statement without false body, and then we have if else statement which have true and false body. Okay, next the third one we have if else if. Okay, we have more than one which we have more than one conditions. Okay, related. Okay, with more than one related. Okay, related. I'm saying this related. We are going to see what's the example of unrelated condition and later on. Okay, so these are related conditions. Next, we are going to see case logic. Case logic structure. So this is also some kind one kind of decision structure. However, the however kan. However, it is slightly different. Okay, how it is different from if and else statement. Okay, there's only one condition symbol will be used in this case logic. Macam ni. Okay, case logic, and also it will divided into how many true condition. Let's say if we have 4 condition and 4 true condition, so it will have 4 branches. 1, 2, 3, 4. Okay, if we have 5 condition, we are going to have 5 lah. 1, 2, 3, 4, 5. In general, okay. However, okay. However, the last condition should be otherwise. So this is similar with the else. Okay, the earlier else that we look at before, and so we have if, else, else, if. The last one is going to be else. So else in the case logic, okay, we replace with this one lah, otherwise. So if the rest of the condition is false, so it will execute otherwise. Okay, get it? You get it? This is less important. Okay, I'm not saying this is unimportant. This is less important compared to the if, else, else statement. Okay, less important. I'm saying less important. All right. So how to use it? Okay. First, switch case can only be used for data related to. Okay, this is wrong. Related to character and integer only. Okay, this is to be precise, okay, because we're going to do the coding for this next semester. Don't want you to get confused with this note. Okay, switch. Okay, the one that we are going to develop is what we call as switch case. Okay, so this is the example for the coding. Example of the coding. If we use case structure, case structure is something like this. Okay, we have switch case. Mostly we call it not case, we call it switch case. But in this subject we call it case. Okay, the one that we are going to use is switch case. This is how we convert it into C program. Okay, there's a switch over there and case. So the one that can be used only character and integer. Okay, codes. Okay, codes ni apa kan? What is the codes? Okay, codes is the condition that we can check. The condition that we can check. Let's look at the example. Okay, straight away look at the example. Okay, Otherwise, you will get confused. Okay, codes kan? Okay, remember codes So in the case statement, okay, case logic structure, we have a code. Okay, so where we put code inside of our structure? Okay, we are going to put the code over here. So this is code. This is what we call as code. This is the code. Okay, understand this first. This is code. Okay, so what does this code represent? Okay, this is the codes represent the value that is checked inside of the decision. So where is the decision symbol? This is the decision symbol. Okay, so what is the code? Code is the value of, in this case, math code. Meaning that math code can be F, can be B, can be K, can be E. Okay, so if the value of math code is F, then what the system will do? The system will give math deduction 0. If math code equal to B, the system will give math deduction value equal to 4.65. Let's go back. Go back to the case study, okay? Confused pula kan case study dah apa. Okay, this is the case study. I think also quite confusing. That's why I show you the flowchart first before you read the problem. Okay, can you understand this, guys? Okay, please read it first for 1 minute. Okay, can you understand? Can you understand the question, class?
Yes, sir.
Yeah. So what is the input? What's the input for this?
4.65.
Initial of company.
This is the output. Ni output and this should be the output. The input should be the what again?
The input should be the plans.
The plan kan. Example of input. Example of input. The value. Give me one value, for example.
F.
For example F. Okay, for example B. For example K. For example E kan. So in this case, there are only 4 value kan for plan. Okay. Alright. So it can be plan lah. So if you write down plan also correct. So let's say we take plan as the input and the output is going to be
4.65. 0.
okay. What? The output is going to be 4.65, 7.85, 5.5, and 0, right? Okay, so what is that? What's the variable that's suitable for that value? All this value.
Medical deduction.
Yeah, medical deduction. So, let's say if user entered F, what is the medical deduction?
Error.
4.65.
Zero lah kan? Because it is said over here, the company pays for all of plan 1. So if user entered plan 1, which is F, so medical deduction equal to 0. Okay. So if you user enter plan B, okay. Ni user enter lah ni kan. Konon user enter. So user entered B. So medical deduction equal to
4.65.
yeah, 4.65. You get it? Okay, so if user enter K, medical deduction equal to 5.50. So let's say if user enter X, medical deduction equal to
Error.
error lah. Okay, something like that. Okay. So this is if you know if you what we said so pula cakap English ni kan. Okay, if you just think about it, since this is simple problem, of course you can get it easily what is the input and what is the output. But if it get complicated, then you really need to come up with the algorithms and also the flowchart. Okay, so how's the algorithms and flowcharts going to look like so this is when we translate it into algorithms. If you are required to use case structure, this is for case structure. Okay, case structure. Not if and else. This is not if and else structure. This is case structure. Biarlah. Yeah. Okay, so it will have the keyword of case of. Okay, this is compulsory. Okay, you must have case of. Okay, and then you must have otherwise, and you must have end of case. Okay, in between where you put the condition. Okay, for example, this is using math code. The one that we use is what? Plan kan? So let's say we use plan. So put it over here. So it is similar to math code kan? Plan. Okay. So if plan equal to F, then math deduction equal to 0. If plan to B, you need to also put this. Don't forget. Okay. What we call this? Double ni. Double dot ni So you must also put this. Okay. Okay, and so on. Okay, so otherwise, okay, if user entered other than F, B, K, and E, otherwise you must print error. End of case. That's it. Alright. Okay. So this statement, codes are character and integer only, meaning that over here, F, B, K, E. So you cannot test, let's say if plan is first. This is not character, right? Is it character?
No.
So you cannot test this. So this is unacceptable for case structure. case structure can only check character or integer. Let's say if plant equal to 20, okay, plant equal to 21, plant equal to 22, plant equal to, let's say example if it is integer, so it is allowed lah if this is integer. Okay, if it is 20.7, is it integer? Is it?
No.
No, right? It is real value, right? So you cannot use case structure. You understand, class?
Yes.
Yes, sir.
Kan? This is just a simple structure, okay? That only applicable for value, character, and also integer only. Okay? Character and integer. Don't use it for any other else. Anything else. So to convert it into a flowchart, this is how it's going to looks like. Okay, one decision symbol. Okay, and then put the variable that you want to check. So in this case, we use plan, right? So case of plan. So what is the value of plan? If plan is F, then it will do this. If plan is B, it will do this. Okay, boleh. So what if we put another statement over here? Let's say if plant is F, okay, it will give make deduction equal to 0, and also it will calculate A equal to 100 times by C, for example lah. For example, okay, this is the statement for F. You get it? Where should I put here? Where should I put the equation inside of the flowchart? A equal to 100 times by C. This falls under plant equal to F. Where should I put it?
Below the medical deduction.
Which medical deduction?
Code F.
Yeah. Alright.
Yes.
Yeah, correct. So it should be here only, kan? After make deduction equal to 10, then we do the equation lah. A equal to 100 times by, apa benda saya buat tadi? C okay. Right, so meaning that for each of the true body, okay, true condition, you can have more than one statement. It can be calculation, it can be input and output, it can be nested decision. It can have, you can also have, for example, over here, we have if statement boleh juga kan? If A less than, example B equal to 100, and E. So this is inside of plant equal to F, correct? So you can have this. So let's say that's the situation, then you need to put if statement there will be if symbol over here. If true what, if else what, and then it will go here. Understand? Boleh Any question?
Sir, can you back again? I don't understand.
Which part?
Yang green, color green.
Huh? Sorry?
Yang color green, yang baru je, yang saya ajar tadi.
Yang ada ni.
I don't get it.
Oh, this I just want to show you that you can have more than one statement for the true body. Okay, for example, if plan equal to F is true. Okay, so currently we just do this statement, right? Make deduction equal to 0. You can also have other statement. Okay, you can have calculation, you can have condition. If you have, let's say this is the example. Let's say if you have if statement for the plan equal to F. Okay, we have if statement. This is the statement. Kan, if A less than 100 times by C, for example. So where you want to put this inside of the flowchart? So we put it below here. We put it below here lah. If F is true, right? Mana tadi? If F is true, then make deduction equal to 0. Okay, make deduction equal to 0. Then we have if over here. Okay, let's say if we have if over here. So if should be put here lah. If kan diamond. So dari diamond lah sini. So dia akan jadi panjang lah. Dia akan ada if it is true, what it will do. If it is false, what it will do. And then finish everything, it will go back to here. This line. Okay? Boleh?
Thank you, sir.
Faham Okay. Okay, for midterm test, how to say this? Okay, so for the midterm test, we are going to focus not on this. Okay, bukan pada not on the case tadi. Okay, sorry, not on the case structure. Okay, we are going to focus on something like this. Okay, so if you want to do any further study, please focus on this for the midterm test. Alright. Alright, so next is the comparison. Okay, so the comparison, this is for only the 3 types of condition. So I already added one more, which is if, else if. So it's supposed to have one more over here. Is we have if, else if, and else. Okay. Right. This. We have 4 types of decision structure. Okay, the basic types of decision structure. Then when we move to the complicated part, okay, we will further divide this into 3 more types. That's the advanced one. Okay. Okay, so let's go back a little bit. Okay, before we come up with all the drawing, okay, all the algorithms of the flowchart, of course, you need to extract all the information by using the PAC first, right? PAC, IC, IPO, then we develop the algorithm. Next, we must have the dash checking first. So if it is correct, then we can develop the codings. Okay. So before we come up with the algorithm and flowchart, first we must draw the PAC. So how's this different between compared to the sequential logic structure ni kan? So of course, if sequential logic structure, we are not going to add the decision part inside of the PAC kan. So in here, we must put the decision part inside of the PAC. So where to put the decision inside of the PAC? Over here. Where's the decision? For example, this is the problem. Okay, can you read this first? Okay, we have some more times over here to discuss about this. Before that, I already look at your timetable kan. So I see that tomorrow morning, 8 p.m. 8 a.m. 8 in the morning kan. Everyone is free, right? Is it correct? C11, 12, and 13. You guys are free, right? Tomorrow morning, 8 a.m.
Yes, sir. Yes.
Yes.
sir.
Yeah.
Yes.
So
Team free.
Is it possible if we move all the labs time into next morning? Into tomorrow morning, sorry, 8 a.m. Boleh?
Okay, sir.
Boleh.
Okay, so instead of doing the lab session separately, so we are going to have one similar time for all the sections. So the time is tomorrow morning, 8 a.m. Okay, so please ready before 8 a.m. Okay, 10 minutes before 8 a.m. So I will share the link for the Google Meet. Is it okay? Any problem?
Okay, sir.
Boleh
No problem.
Okay.
Boleh, sir.
Right. So good. Okay, good. Mana tadi? Alright, so let's continue. No, I think maybe we can end this here and continue tomorrow lah, kan? If that's the case, since we are going to meet again. So let's continue tomorrow. However, for the attendance, you need to submit something alright. So for attendance, simple task. I want you to convert this case logic structure into if else if structure. Ini tak ada ni. Faham tak? Can you understand ni?
Algorithm ke?
No, flowchart. Convert this flowchart into if else if flowchart. Easy, right? Easy. You understand what to do, class?
Using what, sir?
Yes.
Convert this into if else if. You can just draw it. You can use words, you can use PowerPoints, up to you lah, as long as you submit. You don't have to use Raptor lah. Don't have to use Raptor, but if you want to use Raptor also can, no problem. But I haven't explained yet how to draw decision in Raptor kan. So no, you don't have to use Raptor. Okay, just draw it. Okay, boleh?
Okay, boleh sir.
Okay, submit before midnight today for your attendance, okay, for the lecture attendance. So see you guys tomorrow morning 8 a.m. for the labs. Don't forget lab tomorrow 8 a.m. Okay, for all.
Okay, sir.
All right. So see
Okay,
you guys.
sir.
Alright,
Thank you.
sir.
Okay,
Assalamualaikum.
sir. Thank you, sir. Waalaikumsalam.
Thank you, sir.
Sir.
Thank you, sir.
Thanks, sir.
Thank you, sir.
Sir.
Thank you, Doctor.
Ada
Thank you,
soalan ke?
sir.
Sir. Boleh tak tengokkan slide?
Thank you, Doctor.
Apa dia?
Slide yang atas tu.
Yang mana?
Yang 13. The example.
This one?
Um,
Which example lah? Sekejap. This example?
yeah.
This example?
Dan kita kena buat macam ni kan? Tukar yang tadi tu
Ah,
macam
buat
ni
macam
kan?
Yeah.
Oh, okay.
Right, this one
Okay, thank you.
Right.